Welcome to MyProjectBazaar.com. Let we discuss about the process lossless and reversible data hiding in encrypted images with public key cryptography. Let me see the abstract of the process. The rapidly proliferated information and evaluation of digital technologies by information hiding in multimedia data has improved the case of access to digital information, enabling reliable, faster, and efficient storage, transfer, and processing of digital data, and leads to the consequence of making the illegal production and redistribution of digital media easy and undetectable. Hence, it poses a novel challenges for researchers. In this proposed work, a novel integration of incorporating text and image technography to find a solution for enhancing security and protecting data is proposed. Today's data is transferred in public network is not secured because of the interception of eavesdropper. Steganography is a better technique for writing the hidden messages in other file formats like text, image, and videos. In this process, a technique of data hiding using interpolation, least significant bit, and digital watermarking and cryptography is proposed. The performance of the process is tested through measures like adaptive mean square error, measures like mean square error and peak signal to noise ratio, and data embedding capacity. Secret information is obtained from the user. The information is encrypted based on AES encryption process. The encryption information is hidden in the images based on the least significant bit embedding algorithm. The main objective of the process is to embed the secret information in the image and to extract the secret information from the image without producing much distractions in the images. To encrypt the secret information using AES encryption, to the main process is the embedding of the encrypted information using least significant bit process. The originality in the secret information while retrieving is well preserved. The overall performance of the process is measured in terms of the PSNR, MSC, and the embedding ratio. The performance of the process measured indicates that the proposed method can hide data in images more effectively compared to other methods for data hiding process. Let me see the flow of the process. First, we obtain the secret information and the input image from the user. The secret information is encrypted using AES encryption process. The information in text is encrypted using AES format. The message in text format is converted into ASCII code in order to convert the text into numbers. In AES, the following steps were followed. The steps were repeated again and again till the number of rounds. First step is the key generation process. Key is generated for the secret information depending on its size. Instead of giving fixed key, the key is generated based on the size in order to reduce the interaction between the user and the system. Then the add round key process. The generated key is added to the secret information using bitwise XOR operation. Then subbytes, a matrix which is in the size of the column of the secret information is generated and they were referred to as subbytes. The generated subbytes were added to the result of the previous step. Then shift rows. The rows in the resulting update were shifted to the left side. The number of shifts is based on the current row of the secret information. Then mixed columns. The columns in the result update were multiplied with the generated subbytes. After the encryption process, the embedding process is done based on the least significant bit process. Embedding secret information, the encrypted secret information is then hidden in the input image based on LSB embedding process. In the proposed system, the LSB algorithm is used to hide the encrypted data into the encrypted image. At the time of the steganography, each pixel in the RGB formats were separated, and we calculate an enclosed matrix and calculate the alpha values. The calculated alpha values gives the matrix of capability of hiding a sum bit or not. The standard alpha value 0.3 is taken here. If the alpha value is less than 0.3, then we do not hide bits in the matrix, just we neglect it. If the alpha value is greater, means we simply hide the matrix and calculated the alpha value again. If the alpha value is less than zero point 0.3, then change the first bit as 1, otherwise 0. Finally, we get a encrypted SIGO image. As the result, we get a embedding image with this encrypted, and the secret information is also placed here. After that, the same process is repeated in the receiver side by reversing the process in the sender side. First, the embedding process is reversed based on the reversal of the LSB process, and then the encrypted in message and the encrypted secret information and the images were decrypted based on the AES decryption process. Finally, the performance of the process is measured in terms of PSNR, MSC, and the embedding process. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is present in the source code folder. Right click it and click on run file. You will get the process executed. First, we have to select any one of the image. We can select any one of the image here, or we can select any one of the image outside. So we select any one of the input image. First step is we give the secret information, which is in the text format. So I give a message. The message has to be within the size, within the length 64 bits. Since the block size is 8 cross 8, so the message length has to be within 64. Then after we have given the secret information, we have to give the number of rounds in the AES process. So now we give the number of rounds within 5 to 30. So any rounds we have given. So after we give any number of rounds, the process will execute. So as we can see, for each rounds, the AES process, add round key, sub byte, shift rows, mix columns, the process has been repeated, and this is the encrypted in text. After that, the decryption, the receiver side process continues. In the receiver side, first the encrypted text is extracted from the image. So this is the image with the secret information. From this only the encrypted text is extracted. As we can see, the input image is similar to the resulting image. So after that, the same AES process decryption is repeated, and the text is obtained. Finally, we measure the performance based on the performance matrices. This is the image without secret information. The performance of the measures calculated were displayed here. PSNR, MSC, and embedding ratio. The performance of the values indicates that the proposed approach is more improved compared to the existing ones. Thank you.